Hi, welcome back. This is your teacher Fred, and our topic for today is about geometric sequences and series. In an arithmetic sequence such as 2, 4, 6, 8, 10, so on and so forth, there is a common difference between consecutive terms. In a geometric sequence there is a common ratio between consecutive terms. A sequence in which each term after the first is obtained by multiplying the preceding term by a constant is called a geometric sequence. The constant is denoted by the letter r and is called the common ratio. If a sub 1 is the first term, then the second term is a sub 1 times r. The third term is a sub 1 times r squared, the fourth term is a sub 1 times r cubed, and so on. We can write the formula for the nth term of a geometric sequence by following this pattern. Thus the formula for the nth term, a sub n, of a geometric sequence with first term, a sub 1, and common ratio r is a sub n is equal to a sub 1 times r raised to n minus 1. The first term and the common ratio determine all of the terms of a geometric sequence. Let's apply this formula. For example, write a formula for the nth term of the geometric sequence. 6, 2, 2/3, 2/9, so on and so forth. Solution. We can obtain the common ratio by dividing any term after the first by the term preceding. So, r is equal to 2 divided by 6, which is equal to 1/3. Because each term after the first is 1/3 of the term preceding it, the nth term is given by a sub n is equal to 6 times 1/3 raised to the quantity n minus 1. Checking our solution, let us check a few terms. A sub 1 is equal to 6 times 1/3 raised to the quantity 1 minus 1, which is equal to 6. A sub 2 is equal to 6 times 1/3 raised to the quantity 2 minus 1, which is equal to 2. And a sub 3 is equal to 6 times 1/3 raised to the quantity 3 minus 1, which is equal to 2/3. Indeed, the formula for the nth term of the geometric sequence 6, 2, 2/3, 2/9, so on and so forth, is given by a sub n is equal to 6 times 1/3 raised to the quantity n minus 1. Another example. Find a formula for the nth term of a geometric sequence. 2, -1, 1/2, -1/4, so on and so forth. Solution. We obtain the ratio by dividing a term by the term preceding it. We get r is equal to -1 divided by 2, which is equal to -1/2. Each term after the first is obtained by multiplying the preceding terms by -1/2. The formula for the nth term is given by a sub n is equal to 2 times the quantity -1/2 raised to n minus 1. We could check our answer by finding the first few terms. Thus, a sub 1 is equal to 2 times the quantity -1/2 raised to 1 minus 1, which is equal to 2. A sub 2 is equal to 2 times the quantity -1/2 raised to 2 minus 1, which is equal to -1. A sub 3 is equal to 2 times the quantity -1/2 raised to 3 minus 1, which is equal to 1/2. Indeed, the formula for the nth term of a geometric sequence 2, -1, 1/2, -1/4, so on and so forth, is given by a sub n is equal to 2 times the quantity -1/2 raised to n minus 1. We could also use the formula for the nth term to write some terms of a geometric sequence. For example, write the first 5 terms of the geometric sequence whose nth term is a sub n is equal to 3 times the quantity -2 raised to n minus 1. Solution. Let n take the values 1 through 5 in the formula for the nth term. Thus we get a sub 1 is equal to 3 times -2 raised to 1 minus 1, which is equal to 3. A sub 2 is equal to 3 times -2 raised to 2 minus 1, which is equal to -6. A sub 3 is equal to 3 times -2 raised to 3 minus 1, which is equal to 12. A sub 4 is equal to 3 times -2 raised to 4 minus 1, which is equal to -24. A sub 5 is equal to 3 times -2 raised to 5 minus 1, which is equal to 48. Notice that a sub n is equal to 3 times the quantity -2 raised to n minus 1 gives the general term for a geometric sequence with first term 3 and a common ratio of -2. Because every term after the first can be obtained by multiplying the previous term by -2, the terms 3, -6, 12, -24, and 48 are correct. The formula for the nth term involves 4 variables: a sub n, a sub 1, r, and n. If we know the value of any three of them, we can find the value of the fourth. For example, find the first term of a geometric sequence whose fourth term is 8 and whose common ratio is 1/2. Solution. We let a sub 4 be equal to 8, r be equal to 1/2, and n be equal to 4, in the formula a sub n is equal to a sub 1 times r raised to n minus 1. Plugging the values, we get 8 is equal to a sub 1 times 1/2 raised to 4 minus 1. Simplifying, we get 8 is equal to a sub 1 times 1/8. Multiplying 8 both sides, we get 64 is equal to a sub 1. Thus making 64 the first term of the geometric sequence. Consider the following series: 1, plus 2, plus 4, plus 8, plus 16, up until plus 512. The terms of this series are the terms of a finite geometric sequence. The indicated sum of a geometric sequence is called a geometric series. Thus, if S sub n represents the sum of the first n terms of a geometric series with first term, a sub 1, and common ratio r, are not equal to 1, then S sub n is equal to a sub 1 times the quantity 1 minus r raised to n over the quantity 1 minus r. For example, find the sum of the series 1/3 plus 1/9 plus 1/27 up until plus 1/729. Solution. The first term is 1/3, and the common ratio is 1/3. So the nth term can be written as a sub n is equal to 1/3 times 1/3 raised to n minus 1. We can use this formula to find the number of terms in the series, which is given by 1/729 is equal to 1/3 times 1/3 raised to n minus 1. Simplifying, we get 1/729 is equal to 1/3 raised to n. Because 3 raised to 6 is equal to 729, we have n equals 6. Thus plugging it in the formula, we get S sub 6 is equal to 1/3 times the quantity 1 minus 1/3 raised to 6 divided by the quantity 1 minus 1/3, which is equal to 1/3 times the quantity 1 minus 1/729 divided by 2/3. Simplifying, we get S sub n is equal to 1/3 times 728/729 times 2/3, which is equal to 364/729. The sum of the series 1/3 plus 1/9 plus 1/27 up until plus 1/729. Another example. Find the sum of the series. The summation of 3 times -2 raised to the quantity I minus 1 from I equal to 1 up to 12. Solution. This series is geometric with first term 3, ratio -2, and n equal to 12. We use the formula for the sum of the first 12 terms of geometric series. Plugging the values, we get S sub 12 is equal to 3 times the quantity 1 minus -2 raised to 12 over the quantity 1 minus -2, which is equal to 3 times -4095 over 3. Cancel 3, we get minus 4095 as our final answer. If a sub 1 plus a sub 1 times r plus a sub 1 times r squared, so on and so forth, is an infinite geometric series with the absolute value of r is less than 1, then the sum S of all of the terms of this series is given by S is equal to a sub 1 over the quantity 1 minus r. For example, find the sum 1/2 plus 1/4 plus 1/8 plus 1/16 plus, so on and so forth. Solution. This series is an infinite geometric series with a sub 1 equal to 1/2 and r equal to 1/2. Since r is less than 1, we have S is equal to 1/2 over 1 minus 1/2, which is equal to 1. Another example. Find the value of the sum. Summation of 8 times 3/4 raised to I minus 1 from I equal to 1 up to infinity. This series is an infinite geometric series with first term 8 and common ratio 3/4. So, S is equal to 8 over 1 minus 3/4, which is equal to 8 times 4 over 1, which is equal to 32.